Hello guys, before I start my discussion, I'll clarify that these videos are related to our discrete mathematics project, which is inspired by Professor Manish Kumar Gupta, Professor Manoj Rao, and Professor Prasenjit Kundu. And our team members' names and IDs are shown on the screen. First of all, I will introduce myself. I am Smith Fairfer and my student ID is 20220123. So, in this video, I cover the steps included in the Dijkstra'S algorithm. And what will I say in this video? I already wrote in these slides. So it is very easy to understand. So let's start. Dijkstra'S algorithm is a popular graph traversal algorithm used to find the shortest path between a source node and all other nodes in a weighted graph. It is a basically greedy algorithm that gradually updating the shortest path distances from the starting node to each node. So how to use this algorithm, or what is the steps included in this algorithm, which are mentioned in the next slide. And in the graph, each edge has weight or cost associated with it, representing the distance between the connected nodes. In the initialization state, the distance value of the source node is set to 0, while all other nodes are set to infinite initially. Because initially we don't know the distances of all nodes from source node, so we assume that all the nodes are at infinite from the source node. And mark all nodes as unvisited. In second step, choose the closest node among the unvisited nodes. This node will be the current node for the iteration. In the third step, for the current node, consider all of its neighboring nodes that are still unvisited. Calculate the tentative cost from the source node to each neighboring node by summing up the distances from the current node to the neighbor. If the newly calculated distance is smaller than the current distance value of the neighbor, update the neighbor's distance value. In the fourth step, once all the neighbor nodes of current nodes are visited, then mark the current node as visited. A visited node will not be checked again. Repeat upper steps until the goal node will be visited. If the destination node is reached, the algorithm will terminate early. So at the final result, we get shortest path distance from source node to every other nodes. To understand these steps easily, look small example. Consider below graph to understand the steps which are used in this algorithm. Here in this example, we consider source node as first node. Distance from source node to source node is 0. And for other nodes, we don't determine the distances from source node. So we assume that distance of the nodes from source node will be infinite. For further process, we use steps which we learned in previous slides to solve this sum easily. Since we are choosing to start at node 1, we can mark this node as visited and add a star to the corresponding node in a graph. Now we need to start checking the distance from node 1 to its adjacent nodes. As you can see in the diagram that these are the nodes 2 and 3. We need to update the distances from node 1 to node 2 and 3 with the weights of the edges that connect them to node 1, and these weights are 5 and 6 respectively. After updating the distances of the adjacent nodes, we need to select the node that is closest of the current known distances. Mark it as visited. Add it to the path. From the diagram, we can see that the node 2 is closest to source node. So we add it to the path. See the new updated graph. We make a star at a node which is already visited and draw a red line on edge which is included in our path. Now we need to analyze the new adjacent nodes to find the shortest path to reach them. We will only analyze the nodes that are adjacent to the nodes that are already part of the shortest path. So the nodes 3 and 4 are the nodes that we will analyze in the next step. After that, the distance from the source node to the new adjacent node. Distance of node 3 we already add to the list. For node 4, the distance is 15 because we have to add the weights of all edges that form the shortest path to that node. We have to choose which node will be added to the path. We must select the unvisited node with the shortest distance to the source node. So we find the node from graph that is the node is 3. We add it to our path and do a star at that node. Now we need to repeat this process. Find the shortest path for all other nodes. So in our example, the last and adjacent node is 4. From path 1 to 4, the distance is 15. And from path 1, 3, 4, the distance is 40. So the shortest distance is 14. So add this path in our original shortest path, which are in red edges. So we finally get the shortest path from source node to all other nodes using the steps which are covered in previous slides. So the final graph and diagram is given below. So using our steps, we are finding the shortest path between any two nodes in a graph. So these steps are very easy to solve any problem related to finding shortest path in a graph or map. So in this section, we see the steps included in Dijkstra'S algorithm and related small example to understand how actually implement the steps in a problem. Here we only cover small example, but if you are curious to solve other big and unique problem, which is basically solved by these simple steps, then see our next video. Thanks for watching this video.